Okay, so let's move to yet another simple but interesting problem. You have two blocks kept in this fashion. The string is parallel to the plane of the wedge, both the strings, and this angle is given as theta. Take mass of both the blocks same as m or whatever. Now the question is, what should be the minimum value of this theta so that the system starts moving, they no more remain at rest. Okay, so I'm giving you options. Option number A, cos inverse. I didn't give you the coefficient of friction. Coefficient of friction would be mu. Okay, so the first option is cos inverse mu square minus 1 upon mu square plus 1. If there is no friction, this cannot remain stationary at any angle, right? So if somebody is asking a minimum angle, then there has to be friction, because if there's no friction, then the minimum angle will be, you cannot keep it at any angle theta other than 0, because of the component of mg, there will be some force down the plane and the whole system will go down the plane. There's no other force to stop it if there is no friction. So there has to be friction. Option A, I have given you. Option B, cos inverse mu square plus 1 upon 1 minus mu square. Option C, cos inverse 2 mu upon 1 plus mu square. And option D, cos inverse 1 minus mu square upon 1 plus mu square. Okay, so please work this one out. This is simple, and so I'm not discussing it. I'm leaving you with this problem in order to elevate yourself. If you think that this is easy, then solve this problem very quickly, but don't leave this problem in any case. Now the answer is option number D. And I really hope that you got option number D as your answer. I'm not discussing it, this is simple. So draw the FBD, write the equation of static equilibrium, and you will get your answer. That's it. So this kind of problem, after studying Newton's second law and after solving some problems in friction, this kind of problem should actually seem very easy to you, because they are indeed very easy. Okay, so let's move on from this problem to yet another interesting problem. This is a setup. Suppose this angle theta is 30 degree. Okay, so this angle theta will also be 30 degree. Now this rope is horizontal, although it doesn't look so, it is horizontal, and there is friction between both the surfaces, between A and B, and between this M1 and M2 and the wall. And the coefficient of friction everywhere is same. Consider that to be 0.2. Now the question is, at this very moment, what will be the acceleration of mass M2? So you have to find two things. First, find tension in the string. What will be the tension? And what will be the acceleration of mass M2? Fine. So this is interesting. This kind of problem you expect in IIT JEE exam. So you get your answer. Tension and acceleration of the block of mass m2. If this is 10 kg and this is 20 kg. So sorry. This is 10 kg, this is 20 kg. Only then you can find acceleration in a, you can get numerical value of acceleration. Okay, so let me give you the answers and then we'll have a quick discussion. Tension would come out, I think, as 306 Newton, very close to this, 306 Newton, and the acceleration, if you take tension as 306, you'll get acceleration as 4.7 meter per second square. Okay, let's discuss this. Let's start from mass m1. You have to find tension, write the equation of static equilibrium. Write the equation of static equilibrium in vertical direction. In vertical direction, the force upward is T sine 30 degrees. T by 2. That should balance the downward forces. Which are the downward forces? mg, right? This is mg. Downward force plus there will be some friction between A and B. Now see, this m2 under the force of gravity is going to come down. So the force of friction on m2 is going to be upward from both the contacts. So the force of friction on m1 will be downward. So the downward force apart from mg for this is there's also friction, and friction is mu 2 by 10 mu into n. And what is the normal reaction between the contact? Normal reaction is coming from the horizontal component of this tension, which is root 3 by 2 times T. Okay, so this is the equation of static equilibrium for m1 in vertical direction. From here you have to labor a little bit to put the value of root 3 as 1.73, and you have to get to the numerical value of T, but you will get T as 306. Okay, now once you have got T, and then you have to look for acceleration of m2. For that it's pretty simple. You know that the horizontal component of tension will become the normal reaction here, and the force of friction is mu into n, and n is root 3 by 2 times T, and T you have calculated as 306, and mu is given.